In the second part of the electrochemistry, we are looking at aqueous. All right. When we have aqueous, then this is the big difference. Right? Aqueous means there is water involved. And water, when they go through electrolysis, actually they will split into the H plus and OH minus. Right? So you can see that it's the same thing, all right, just that now, okay, when we talk about aqueous sodium chloride, we have it additional Na plus, I mean we have the H plus, we have the OH minus. That means now we must make a choice because at any one time, only one ions can be uh, discharged. We call it discharge. Okay, when from charge to no charge is a discharging process. All right, so these are the rule. Okay, cation ion only one rule. We base on the reactivity. The less reactive will be preferred. All right, for anion, okay, there is of course there's the electrochemical series. Technically, normally hydroxide will always be right because sulfate nitrate are actually much more higher than hydroxide. So normally they won't. Hydroxide is one of the least reactive, right? Okay, unless there's a concentration, but concentration only affect the group 17. That means if you see concentrated sodium chloride, concentrated sodium fluoride, or potassium fluoride, all these group 17, then you will overrule. So we can see for ourselves here. All right, see same thing. Okay, cathode, no issue. All right, between Na plus, H plus, of course, hydrogen is less reactive than hydrogen. They are selectively discharged. Then, of course, between Cl minus and OH minus, all right, it's a dilute one. So technically, OH minus will be selectively discharged. Now, this one is something that we have to memorize. Okay, because it's not so straightforward. It's not an element. There's two elements here, oxygen and hydrogen. Right, so we can see effervescence because we see oxygen gas and hydrogen gas. All right, and if you combine, because due to selective process, all right, it's actually a decomposition of water because H plus and OH minus come from water. So if you write a decomposition of water, you will actually see that the hydrogen and the oxygen is 2:1. Right? Or from the half equation, we can see you must understand that whatever electron that is lost at the A node will go to the cathode. So if 4 moles of electron lost, you only form one oxygen. But 4 more electron gain at the cathode, you will form 2 moles of hydrogen. That's why the ratio is always of oxygen to hydrogen is always, or the hydrogen to oxygen is always 2:1. So of course, when the water will be slowly removed, and of course the solution will become more concentrated. But now if you use concentrated, see the main difference is always at the A node. Now chloride will be discharged because we mentioned concentration for group 17. Right? So that is a higher chance. Okay, because hydroxide and chloride they are not very far from one another. So when it's concentrated, basically means it's more nearer to you. So similarly, right, if today the exchange rate between Singapore and Malaysia is just only 1.5, then you will not travel so far to buy the things. You might as well travel nearer, right? Concentrated means near to you. And in this case, we can see that, right, the ratio is 1:1. Okay, same thing in effervescence because you got hydrogen gas, you got chlorine gas, right? And looking at the mole ratio here, see all the two electrons, the anode will lose to the cathode. So that's why the ratio will be 1:2. And because H plus is selectively discharged, that's why, okay, the concentration of hydroxide will actually be more than the hydrogen, making it more alkaline, okay, as the electrolysis progress. All right, let's try to look at another example. Okay, now see copper 2 sulfate. Now whether it's concentrated or not, okay, sulfate will never be discharged. So at the end of the day, it's still your OH minus that's still discharged. And between hydrogen and copper, actually copper is even less reactive than the hydrogen. That's why copper cannot react with acids. The rest are quite similar to what we have discussed in the earlier scenario, right? And having to note that actually we are doing all this electrolysis using inert electrode, all right? Inert electrode. So normally platinum or graphite, that means we don't need to worry about them. They are just as a platform to allow reaction to take place. But just take note for graphite. Graphite is actually carbon, okay? And actually at the A node, especially when you produce oxygen, the carbon will actually react with the oxygen to give you carbon dioxide. So the graphite electrode do become smaller, right? But that is not because of a reaction during electrolysis, it's a reaction after electrolysis. So it's still considered inert, right? And of course, for cathode, there's a chance to grow in size because you form copper, then you will see become bigger, you will see reddish brown deposits form. So that will be for the electrolysis of aqueous solution. We need to beware of the selectivity rule. Okay, catch the next video for the electrolysis using a reactive electrode.